Welcome back to our class video. So in today's class video, I'll be taking you guys our very first class in chemistry. Okay, so this is our very first class in chemistry. Okay, so this class is the video is divided into three categories. So before I continue, the part of Chem 101 which I'll be taking you guys today is atoms and molecules. Okay, so these are the outlines for today class. Okay, so the very first part is talking about atomic theory. We are talking about the early ideas about atom, modern atomic theory. Then the next category, which is structure of atom, talk about the electron, who discover it, the mass of electron, the charge of electron, X-ray, radioactivity, proton, nucleus, neutron, and so on. Then in this last category, we do calculations. Okay, this last category is known as mass relationship of atoms. In this part, talk about atomic number, talk about mass number, how to calculate them and all. And the most important part is this other aspect, which is chemical formula. So in this part, talk about to do the calculations on empirical formula as well as calculation on molecular formula. So please stick to the end of today's video, and also don't forget to like and subscribe, as well as share this video to your friends and to your classmates. Okay, so now let's start with the class video. Now let's start with the very first part of the class, which is atomic theory. Okay, yes. Now, under atomic theory has to do with the early history about, it has to do with the early history about an atom, who discovered it and all. Okay, yes. Now the early ideas about matter. Democritus, a Greek philosopher known as Democritus, was the very first person that brought about the word known as atom. Yes, he was the first person that proposed. Democritus was the first person. He was a Greek philosopher. Okay, so Democritus was the first person to propose that matter is made up of a tiny particles. Yes, he was the first person to propose that matter is made up of a tiny particles, and he called those tiny particles atomos. Yes, he called those tiny particles atomos. And atomos means what? Which means indivisible. Okay. Now atom is gotten from the word atomos. Okay, which means indivisible. Okay. Yes. Now, was this idea really accepted by other scientists? Because if you look at it, Democritus was not a scientist, he was a philosopher. I don't know if you understand. So the idea was philosophical, but not scientific. This idea because normally, take note that Democritus was the very first person that talked about an atom. Yes, Democritus was the first person talking about an atom. He said that matter is made up of a tiny particle called atomos, so you can just simply say atoms. Yes, which means what? Indivisible. Now take note that the word atomos is a Greek word, and apart from that one, Democritus was a Greek philosopher and was not a scientist. Okay, now this idea that he brought about atom, that matter made up of a tiny indivisible particle, this idea was not proven experimentally. So this was why it was not accepted. Okay, yes, it was not accepted, and the idea was philosophical, not scientific. Okay, it was not accepted by scientists. It was not accepted by other persons like Aristotle, Plato, and all. Okay. Now let's move to the next part, which is the modern atomic theory. Now, after Democritus has given his own idea, or his own postulate or idea about atom, then we move forward to a scientist known as John Dalton. Yes, John Dalton. John Dalton gave his own theory about an atom. He gave three main postulates about an atom. Now, John Dalton is regarded as a father of He's regarded as father of atom because why? He was the very first person to, though he was not the very first person to talk about atom, but he talked about atom, and he carried that experiment that proved that um he get three main postulates about an atom. He said that elements are made up of atoms. Yes, he said that elements are made up of atoms, that atoms of the same element are identical. Okay, now let's continue. So he gave three main postulates. Okay, this modern atomic theory, this three main postulate was given by John Dalton. Okay, yes. After Democritus have given his own idea, the next person to talk about an atom is John Dalton. He gave his own theory about atom. He gave three main postulates about atom, that elements are made up of atoms, that atoms of the same element are identical. Okay, yes. Now, is this really true? Is this really true that atoms of the same element are identical? No, this postulate or this theory is not really true. Atoms, though most atoms of the same element are identical, but not all atoms. I don't even understand. Not all atoms of the same element are identical. Now there's a process, there's a phenomenon known as what? Known as isotopy. Okay, known as isotopy. This process, isotopy is a process whereby atoms of the same element have the same atomic number but different mass number due to what they are not due to difference in neutron number, right? Yes. So due to discovery, now this first postulate that atoms of the same element are identical is proven wrong. Yes, this first postulate is proven wrong by the discovery of isotopy. Now let's say for example, that, remember hydrogen as, let's use hydrogen as a case study. Now hydrogen has what? Hydrogen has three isotope, right? Hydrogen has three isotope: protium, deuterium, and what? Tritium, right? Yes. Now, these three atoms are they not atoms of the same element? Yes, they are atoms of the same element. They are atoms of hydrogen, right? Yes. But are these three atoms, are they the same? No, they are not identical. They are not the same because why? Because of what? Isotopy. Because these three atoms have this different mass number. So this very first postulate, or this very first postulate of John Dalton is not correct. I don't know if you understand. It's not that it's not correct. Like, you understand? Okay, let's say okay, it's not correct. Okay, yes, that, well, atoms of the same element, though some are identical, not all atoms of the same element are identical because of what? Because of the discovery of isotopy. But in if you are asked maybe in an exam question or anything, and they tell you to give the main, they tell you to state that in theory, state the exact law, they state this theory. I don't even understand. Even though we know that there are some slight mistake in the theories. Okay, yes. So now let's move to the next part, which is compounds are formed by combination of atoms. Yes, this is very true. Now, look at this other part. Under these compounds are formed by combination of atoms. Atoms combine in small whole number. Yes. Now this other postulate is correct. Yes, but we all know that in organic chemistry, atoms combine. Now, if you look at this postulate only works in inorganic chemistry, where atoms are combined with small whole numbers. For example, let's say hydrogen. Okay, I'm coming. Now, let's say hydrogen reacting with oxygen to form water, right? Reacting with oxygen to form water. Now, okay, let's just use water as a case study. Now, if you look at water as a case study, these two elements, water is made up of hydrogen and oxygen, right? Yes, these two elements, they are in what? They are in a small whole number ratio. 2:1, right? Hydrogen is 2, oxygen is 1. So then it's a small whole number ratio, yes. But due to in organic chemistry, this postulate is not regarded to be true because why? In organic chemistry, atoms combine in large whole numbers. Yes, atoms combine in large whole numbers. Okay, so this postulate is not also regarded to be let's say to be true or not. But if you are asked to if you are asked to state the theories and all, state it the way it is. Yeah, chemical reactions involve rearrangement of atoms. Under this part, atoms are not created, atoms are not destroyed. So these are the main postulate of about atom given by John Dalton. Now this part, atoms are not created, atoms are not destroyed. Okay, now due to the discovery of radioactivity, this last postulate is not also regarded to be completely true, because why? In radioactivity, such as nuclear fusion, such as nuclear fission, as well as nuclear fusion, nuclear fusion. Now, in radioactivity, atoms are usually created. Yes, atoms are created. Radioactivity proved this to be incorrect. I don't know if you understand. In radioactivity, atoms are created and also atoms are destroyed. Yeah, by what? By nuclear fission. Atoms are destroyed by nuclear fission. New atoms are created by what? Nuclear fusion. Okay, so all these are there are many theories, there are many atomic theories about atom. Now let's just continue. Okay, so important you need to take note of is that the very first person to talk about an atom is Democritus. Okay, yes, but the idea was not accepted because it was not proven. It was not proven. Yeah, it was not proven experimentally. Okay, now apart from that one, under that atomic theory, there's still another one that says that atoms and elements is indivisible. That is not cannot be broken down into smaller pieces anymore, of which is still incorrect. Yes, because we all know that atoms is made up of proton, neutron, and electron. Okay, so now let's move to the next part, which is the structure of an atom. Part which is the structure of the atom. Now, atom is made up of. We all know that atom is made up of electron, proton, and what? Electron, proton, and neutron. Right? Yes, electron, proton, and neutron. Now, this is one of the things that is atomic theory missed. Now, in that atomic theory, that is said that an atom is indivisible particle. So, but with experiment, it was found out that atom is divisible. The atom is made up of three subatomic particles, which are electron, proton, and what? Neutron. Okay. Now let's talk about electron. Now, how was electron discovered and all? Okay, so the discovery of electron. Electron was discovered from what? From the cathode ray tube experiment. Yes, this experiment was conducted by J.J. Thomson. Okay, yes. Now, during that discovery of electron was first called cathode ray. Okay, electron was first called cathode ray. Electron was first called cathode ray. Now, what are the properties of what are the properties of cathode ray? The properties of cathode ray is that cathode ray are negative charge particles. Yes. Now electron was first called cathode ray because it was produced from the cathode in a cathode ray tube. I don't understand. So it was produced from the cathode of a cathode ray tube. Yes. Now it was found that when the ray was produced, the ray usually moved from the cathode towards the anode. And remember, anode is positive and the cathode is negative, right? So it was found that when this ray was produced at a very high pressure, at a very high voltage and low pressure, when this ray was produced, it was found out that the ray the ray traveled to the positive terminal in the cathode ray tube. That is, it moved to the anode. So that is why it's said that cathode ray is a negative charge particle. It's a negative charge particle because cathode ray or electron is a negative charge particle because it travels to the positive terminal or to the anode in the cathode ray tube. So the important thing you need to take note here is that electrons, or you can say cathode ray, is a negative charge particles. Now, apart from that one, It travels in what? In straight line. Travels in straight line and cast shadow of opaque objects in their place in their path. Okay, yes, electrons or cathode ray, they travel in a straight path. This part is very important. Okay, yes. Then the last part is that electrons or cathode ray, they can be that they are deflected by what? Electric and magnetic field, of which is very true. Now if you place an electron in an electric field, you find out that electron usually deflects. Usually deflects towards the positive plate in an electric field. Yes, that's to tell you that that's to tell you that electron is a negative charge particle. Okay, yeah, it's deflected by what? Electric field, as well as what? As well as magnetic field. Now when an electron is placed in a magnetic field, it usually deflects. Yes, it will deflect towards the north pole. Yes, it will deflect towards the north pole in a magnetic field. So in summary, to the properties of cathode rays, that is negative charged particles, they travel in straight line and cast shadows of opaque objects in their path. Then it is deflected by what? By electric and magnetic field. Yes. Now cathode ray, electron, which was formerly called cathode ray, was covered by who? By J.J. Thomson. Yes, but it was covered by J.J. Thomson. And with what experiment? How did you discover it? Which experiment? It was what? The cathode ray tube experiment. Okay. So electron was covered by what experiment? By cathode ray tube experiment. Okay. Yes. And now apart from that one, J.J. Thomson determined the charge to mass ratio of electron. Now the charge to mass ratio of electron is determined to be minus 1.76 times 10 raised to power what? Raised to power 8 coulomb per gram. Okay, so this is the what? This is the charge to mass ratio of an electron. Now let's move further to the charge of electron. Now the charge of electron was determined by Millikan. Yes, and with what experiment? It was determined by Millikan in oil drop experiment. Okay, so the charge of electron was determined by who? By Millikan in an oil drop experiment. Now, apart from determining this is the charge of an electron. The charge of an electron is minus 1.6 times 10 raised to power minus 19 coulomb. So this is the charge of an electron. Why this is the mass? This is the charge to mass ratio of an electron. Okay. So in the oil drop experiment, this was the experiment in which Millikan used to determine the charge of an electron to a minus 1.6 times 10 to the minus 19. Yes. Now, apart from determining the charge of an electron, apart from determining the charge, it also determines the mass of an electron. Yes, with the help of this value, with the help of the charge to mass ratio of an electron. Now, charge to mass ratio of an electron. Now, remember this charge to mass ratio of an electron. This quantity, charge to mass ratio of an electron. This quantity equals charge. This quantity equals charge over what? Over mass. Okay, this quantity charge to mass ratio. This quantity is equals to what? Charge over what? Charge over mass, right? Yes. Now, with the help of this charge to mass ratio and the charge of an electron, the Millikan also use these two information. He also use it to determine the mass of an electron. Okay, if the charge to mass ratio of an electron is minus 1.76 times 10 raised to power 8, then we know the charge, right? The charge of an electron is what? Minus 1.6 times 10 raised to power minus 19, right? Then do we know the mass? No. So from the charge to mass ratio of an electron and as well as the charge of an electron, Millikan use these two to determine what? To determine the mass of an electron. So if we determine the mass of an electron, we make a standalone, we arrive something like this. We arrive something like this. Okay. So this negative cancel negative. Now let's divide it. Okay. So if we divide the two values, when we divide the two values, we find out that coming 1.6 times 10 raised to power minus 19 divided by 1.76 times 10 raised to power 8. Yeah, when we divide it, we find out that the mass of an electron is determined to be what? The mass of an electron is determined to be 9.09, then times 10 raised to power times 10 raised to power minus 28. Yeah, times 10 raised to power minus 28. So from these two information, Mele can determine the Mele can determine the mass, as it determine the mass of an electron. So let's tell you that Mele can does two things. It determines the charge of an electron as well as what? As well as the yes, as well as the determine the mass, the charge of electron as well as the mass of an electron. So now let's move to the next part. So let's continue with the next part, which is X-ray and radioactivity as well as proton and nucleus. Okay, so when you see radioactivity here, I just want to talk a little about radioactivity. Okay, but in our next videos, we do X-ray is a topic on it. I mean, radioactivity is a topic on its own. Okay, so now let's continue. Now, X-ray and radioactivity. X-ray. What do you know? What do you understand by X-ray? X-ray is one of an electromagnetic wave, and X-ray was discovered by scientists known as Wilhelm Röntgen in I think in 1895 or so. Okay, 1895 or 1865 or so. Okay, so now in 1895 was discovered by X-ray was discovered by Wilhelm Röntgen when he bombarded metals like when he bombarded heavy metal like tungsten with an high energy electron. So when he bombarded that metals with when bombarded the metal with high energy electron, the metal emits a radiation known as X-ray. So it was one that discovered X-ray. Okay, so now what are the properties of X-ray? X-ray is not a charged particle. Okay? X-ray does not have charge. X-ray is not deflected by magnetic field, it's not deflected by electric field. Now let's move to radioactivity. Okay, like what I said earlier, I told you guys that I will just talk a little about radioactivity. Now, what is radioactivity? Radioactivity is the spontaneous emission of radiation by a radioactive substance. It can be a radioactive element. Okay. Now, the word radioactivity was given by a woman known as was named. The word radioactivity was named like this name was proposed by a woman known as Marie Curie. Okay, Marie Curie. Okay, so Marie Curie named this process radioactivity. Remember, radioactivity is the spontaneous emission of radiation by radioactive substance and all. But the father of radioactivity is Henry Becquerel. Okay, Henry Becquerel. Okay, I don't know if I spell it well, but this is the father of radioactivity is Henry Becquerel. Then who gave that process the name radioactivity is Marie Curie, who discovered X-ray. We were on it Röntgen. Okay, that was in 1895 or so. Okay, so now radioactivity is a spontaneous emission of radiations by a radioactive substance. Now there are three types of radiations. Okay, there are three types. There are three types of radioactive ray, which are we have alpha ray, beta ray, and gamma ray. Okay. Now alpha particles, they are what? When we get to radioactivity on its own as a topic, I will explain better. Okay. Just know that alpha particle they have charge of +2. Beta particle, also known as electron, they have a charge of -1. Then gamma ray has no charge. Okay, gamma ray has no charge. It has no mass. Okay, so gamma ray is also a high penetrating radiation. Okay, so this is all you need to know about X-ray. Okay, now move to the next part, which is proton and nucleus. Now remember, J.J. Thomson was the one that discovered electron, which he first called cathode ray, right? Yes. Now J.J. Thomson also gave his own model about the proton, and this model is known as the Plum-Pauling model. Now this model said that atom is a positive pair. He said that an atom is a positive sphere embedded inside is electron. Yes, but this model was proven to be what? To be false, was proven to be wrong. Okay, so this model about an atom is wrong, okay, because an atom is not a positive sphere. Okay, now move further to Rutherford's Goldfall experiment. Rutherford Goldfall experiment. Now it's with this experiment that Rutherford discovered proton, discovered the nucleus and all. Okay, now please take note that the word proton was first talked about, was first discovered by a scientist known as Eugene Goldstein. Okay, Eugene Goldstein, Eugene Eugene Goldstein. Okay, Goldstein, Eugene Goldstein. Okay, so Eugene Goldstein was the very first person that discovered that talked about proton. Yes, Eugene Goldstein. Okay, Eugene Eugene Goldstein. Okay, so Eugene Goldstein was the first person. Okay, now when he discovered it, he called it, he named it canary. Okay, so that's to tell you that proton was first called canary. Okay, and proton was first discovered by what? By Eugene Goldstein. Okay, then fast forward to Rutherford Goldfall experiment. Now this experiment was used to discover proton and nucleus, right? Now this Rutherford Goldfall experiment. Now during this experiment, which was conducted, please take note that this experiment, Goldfall experiment, was not conducted directly by Rutherford. It was conducted by the two students of Rutherford under the supervision of Rutherford. I don't know if you get. So Rutherford was just supervising them, but those two students, Giga and Mandel, were the two persons that you had there that actually performed the experiment. Okay, but under the supervision of what? Of Rutherford. Now, during this experiment, gold 4 was bombarded by high energy alpha particle, and it was found that most of the alpha particle passed through the gold 4. Few of them were deflected, while few bounced back. So it was from this experiment that Rutherford gave the nuclear. It was for this experiment that he gave nuclear law. It was on this experiment that he discovered nucleus and proton. Okay, so he gave the nuclear law that an atom is made up of a positive charge. Yeah, he said that an atom. Okay, let me just give you. He said that an atom is made up of a positive charge center. Okay, yes. So it was from the experiment that he said that an atom is made up of. Remember, in the Goldfall experiment, he bombarded what? He bombarded gold 4 with alpha particle, and most of them passed through, right? Few were deflected, while some bounced back. So it was, remember, alpha particle, they are what? Alpha particle are positively charged particle. So it was from this experiment that he came up with the nuclear theory and nuclear law, and apart from that one, most of the alpha particle pass through the gold 4. So that's to tell you that atom is made up of a large empty space. Okay, yes, made up of a large empty space. Some of them will bounce back. So remember, positive charge and like charge, they repair. So some of these alpha particles, they do what? They bounce back. So that's to tell you that, oh, the center of the atom usually contain what? A positively charged particle. So this is where he gave nuclear law that state that an atom is made up of a positive charge center where all of its mass is concentrated. Okay, where all of its mass is concentrated, this positively charged center is called what? Is called the nucleus. Okay, yes, revolving around the nucleus is the electron. Okay, so Rutherford Goldfall experiment was used to discover proton and what? And nucleus. Okay, now the mass of proton is found out to be what? 1.67 times 10 to the minus 24, whereas the mass of electron is 9.09 times 10 to the power minus 28 gram. So let's tell that the electron is very, very light. Okay, so from this you find out that proton is what? Is 1840 times heavier than what? Heavier than the electron. Okay, now let's move to the next part. All right, so move to the next part, which is neutron, and the last part, which is mass relationship of atoms. Okay, now the neutron, remember the atom made up of proton, neutron and electron. Okay, these are the three subatomic particles in the atom. Okay, and neutron is one of them. Okay, yes, neutron was covered by who? Neutron was covered by James Chadwick. Okay, James Chadwick was saying that discovered neutron, and also take note that neutron has no charge. Yes, and it's slightly massive than the proton. Okay, so these are all the things you need to know about neutron. Okay, who discovered it? Neutron was discovered by James Chadwick. Neutron has no charge and is slightly massive than the proton. What about proton? Proton was discovered by who? Proton was discovered by Rutherford. Okay, yes. Remember, proton was first talked about by Eugene Goldstein. He called it, or he named it, canary. Okay, yes. Proton is positively charged. Yes, positively charged. And no, where about electron? Electron is negatively charged, and it was discovered by J.J. Thomson. Was formerly called cathode ray because it was produced from the cathode. Okay, but because produced from the cathode in the cathode ray tube. Now, so these are you need to know about the subatomic particles. Now let's move to the actual part now, where we do a lot of calculations. Now, mass relationships of atom. Okay, we have atomic number, we have mass number, then we also deal with chemical formula such as empirical formula and molecular formula. Now, what is atomic number? Now, atomic number is the number of proton in an atom. Okay, in the nucleus of an atom, number of proton in the nucleus of an atom. Okay, in the nucleus of an atom, that is known as atomic number. Okay, so now if I may ask a question now, this is an atom. This is an atom of lithium. This atom has 3 electron. Now, what is the number of proton in this atom? What is the number of proton in this atom? Now, if you look, remember this part is the nucleus, right? Yes. Now, how can I know whether the number of how can I know the number of proton in the nucleus? Yes, but if you look at this diagram did not just tell us that, oh, this is the number of proton, right? Yes. Now, how can you know the number of proton in a neutral atom? Now, it's very, very easy. Okay, just take note that in a neutral atom, the number of proton in a neutral atom, usually equals number of what? Number of electron. Okay, so how will I know the number of proton in this atom? I just need to count the number of electron. Number of electron equals number of proton. That is in a neutral atom. Okay, so a neutral atom is an atom that has not reacted yet, that has not lost or gained any electron. Okay, so this is a neutral atom. The atom has not reacted yet. Okay, so the number of electron here is what? Is 3. So therefore, the proton number of this atom is what? Is 3 as well, right? Yes. Now remember, what is atomic number? Atomic number is number of proton in an atom. Okay, number of proton in the nucleus of an atom. Now, since the number of proton in an atom equals number of electron, so therefore an atomic number can also be defined as what? The number of electron in an atom. Okay, yes. So but if they ask you what is atomic number? Atomic number is number of what? Proton in an atom. Okay, it can also be number of electron, right? Yes, just take note that number of proton in an atom equals number of what? Equals number of electron. Now, move to the next part, which is mass number. What is mass number? Mass number is number of what? Mass number is the number of proton and what? Neutron in an atom. Okay, that is known as what? That's known as the mass number of an atom. Both proton, the mass of number of proton and number of neutron in the nucleus of that atom gives you what? Gives you the mass number. Okay, so that is just it. Okay, now mass number equals proton and neutron. Okay, now let's bring a particular atom. For example, beryllium. This is beryllium atom, right? Now this is a beryllium atom, right? Where is the atomic number? Where is the mass number? Now the atomic number is usually at where? Usually at the subscript. Usually at the subscript of the symbol of an atom, right? Yes. Where about the mass number? Mass number is usually at what? At where? The superscript. Okay, superscript of an atom, right? So this is the mass number, this is what? This is the atomic number, okay? So remember atomic number is what? Atomic number is just equals to what? Number of proton, right? Yes. So atomic number just equals what? It just equals number of what? Number of proton in an atom, right? Yes. Where mass number is number of proton and neutron, right? Yes. Now I told you guys that if you want atomic number is usually at where the subscript of the symbol of an atom, whereas the mass number is usually at where at the superscript of the symbol of of the symbol of an atom, right? Yes. Now if you ask a question calculate such as this one, give the numbers of proton, neutron and electron in each of the following species. As simple as this question is, they usually set it in exam, okay? They usually set it in exam. Now if they ask you give the number of, let's just do a question now, give the number of proton, neutron and electron in each of the following species. Now let's use the very first which is beryllium, right? Yes. Now how many proton is in beryllium? It's very easy. Remember I told you guys that number of proton in an atom is known as what? Atomic number, right? Number of proton in an atom is known as atomic number. And where is atomic number here? This is atomic number. So atomic number, which is what? Number of proton in an atom, right? So therefore this is what? This is proton, right? This is proton number. This is atomic number, right? Which is the same thing, right? Which is number of proton in an atom, right? So therefore the number of proton in this atom is what? Is 5, right? Yes. Now what about neutron? What about the neutron? Okay, now how can you calculate neutron in this atom? It's very easy, okay? Now remember mass number is what? Mass number equal what? Equal proton plus 1 neutron, right? Now where is the mass number in the symbol of an element? This is mass number, right? So the mass number in this element is what? Is 11, right? Now what about the proton number? This is proton number. Remember proton number is what? Is number, this is proton number, right? Which is the atomic number. Atomic number is number of proton in an atom, right? So this is proton number, which is what? 5, then plus neutron. That's what we are looking for, right? So it's very easy. Take this on this other side. 11 minus 5, which is equals to n, right? So 11 minus 5 is 6. So therefore the neutron number of this atom is what? Is 6. Now what about electron? I told you guys earlier that in a neutron atom, the number of proton equals number of electron, or number of electron equals number of proton. Now how many protons in this atom is 5. Therefore the number of electrons is still also 5, right? Yes, I've told you guys earlier that in a neutron atom, number of proton equals number of electron. Yes, and vice versa. Okay, so this is how you can calculate. If they ask you in your CHM101 exam question, if they ask you, they say, okay, they usually ask question like this. If they ask you calculate to get the number of proton, neutron, electron, blah blah. So it's just this method. Okay, it's very very easy. Now let's do this next part. Okay, let me be fast. Now this is a mercury atom, right? Yes. Now this is a mercury atom, right? So this is the mass. This is the atomic number, which is number of proton. What is the mass number? Now let's just look at number of proton, right? Number of proton here is what? Is 80, right? Yes. Electrons still be what? Electrons will be 80, right? Remember, number of electron equals number of proton. Then what about number of neutron? It's very easy. You need to just number of neutron. Remember, mass number is equals to what? No, mass number equals to what? Number of proton plus number of neutron, right? Yes. If the mass number of this atom is what? 199. The proton is what? Is 80. Then plus n, right? So if we make n stand alone, 199 minus 80 will give us n. So what 199 minus 80? 199 minus 80 is 199 minus 80 is still 199, right? I'm coming to my everything. 199 minus 80 is 119. Okay, it's 119. So the neutron number here is what? Is 119. Okay, now let's do the last part. This other one, Hg80, then 200. Now proton number is still what? Proton number is still 80. Electron number is still 80. What about neutron number? Is very easy. Remember, mass number equals what? Equals proton number plus what? Neutron number, right? mass number of this atom is what? Is 200, right? Yes, proton number is what? Is 80, right? So make it stand alone, right? So 200 minus 80 will give us number of neutrons, right? So 200 minus 80 will give us, I think that is 120 now, right? So 200 minus 80, that is 120. So the neutron number here is what? Is 120. So this is how you can calculate. This part is very easy, okay? So this is how you can calculate for number of proton in an atom, number of electron in an atom, number of neutron in an atom. Is very, very easy, okay? Now let's move to the next part, which is chemical formula.